I'm going to be going over the event operations methodology that the River Forecast Center uses within the province of Alberta. There's a couple pictures that I'm going to talk about and discuss, and then at the end, if we've got time, because every time I give this presentation it seems to get longer and longer, and I apologize for that, some of the initiatives, workshops, projects and contracts that we have underway within the group. So in terms of a team mandate, we essentially have 4 functions within the River Forecast Center, with the main goal of enabling Albertans to make decisions about water supply and emergency response planning. The main one here is real-time flow forecasting and support. We have approximately 180 different groups within our flood notification system for the province. Those groups range from local emergency managers, we've got First Nations, industry, federal, provincial and private parks, the NRCS out of Portland for the milk water supply, and we also have Water Security Agency in Saskatchewan as well. We also do near real-time data quality management. So essentially that's doing shift corrections on the fly during operations. That also means maintaining the provincial problems log, and that's essentially a database that we help manage that helps our own monitoring staff as well as Water Survey of Canada manage the maintenance of the hydrometric network. We do daily natural flow forecasting, so that's a very simplified naturalization of the flows for operational purposes within the province. Really it is just managing the effects of the reservoirs upstream, and then we do in the springtime period a monthly water supply forecast. That's a little different than the operational side during floods themselves. This is an attempt to get a volumetric forecast, March to September flow volumes for approximately 20 locations in the province. That's done using principal component regression relationships that have been developed between fall precipitation, current snowpack, current precipitation, and last month's natural flow values. In terms of what the methodology actually looks like, this is a very pared down version of what we use within the River Forecast Center. The real one is about 3 pages tabloid sized long. I don't want to subject you that after lunch. I know everybody had a great lunch, but it's kind of hard to focus sometimes. So essentially what it is a series of escalating decision points. At the base level, we have forecaster on duty tasks. So we have forecasters on duty between the months of March and October. Essentially they're on shift for weekly periods at a time. They're carrying a duty phone and they have tasks during the period of time that they're on duty. They're required to monitor stream flow across all of Alberta at all the stations that we look at, precipitation that's occurred within the last period of time since they've taken on the shift. They're looking at snowpack, snow water equivalent, soil moisture, as well as what's coming out of the weather models in the States from Environment Canada, what our own fires weather group does, and other sources like that. If those meteorologists see an event coming, typically, they'll be letting us know about those events when they're sitting off the coast of Alaska. So it takes approximately, on average, 3 to 5 days from the point at which they see that large synoptic low pressure system sitting off Alaska for it to move down the coast of BC. It may or may not make landfall through the province of British Columbia. Sometimes it will go into the Pacific Northwest. That's usually the ones that will come and wrap around that we were talking about a little bit earlier this morning. And then finally, once it's made its way and crossed the divide, we know what's going to happen with that system. Between it appearing off the coast of Alaska and it crossing the divide, at some point the meteorologist will give us a forecast for storm totals for the duration of the event, and hopefully broken down into 6-hour increments. With that information, we can do preliminary risk assessment model runs. In this box here, the main purposes of that is to make a decision as to whether the event's going to be a low risk event, medium risk, or high risk. If it's low risk, you're right back into the daily operations that you were at before. Medium risk or high risk, if it's high risk, we're going to go into our 24/7 operations. That's essentially taking the 5 forecasters we have in the province and the 4 technologists that we have, subdividing them into 2 12-hour shifts that run from 7 a.m. to 7 p.m. until the duration of the event is over. In both the medium and high cases, we're making a couple sets of sort of qualitative, quantitative kind of discussions with a bunch of different groups. Monitoring groups, our own provincial groups, Water Survey of Canada get contacted. They've got to get boots on the ground, and typically, if you've been around long enough, you know these events are always on a weekend, and it's always in the summertime. So everybody's got to sort of get their people together, make sure they've got staff for the upcoming event. We're also calling our operations infrastructure dam operators. So we've got a couple of dams within the province. The big ones we talk about a lot are Dixon Dam and the Red Deer. We've got Old Man Waterton and St. Mary in the south. Twin Valley on the Little Bow played a role this year as well, and then there's the Paddle in the north, but there's a couple of smaller structures as well. And they have to man up, get their plan in place as well as for the amount of precipitation we're expecting. And then there are calls made to flood-prone communities, not exactly with a flow value and a time to peak, but what the risk is potentially for their communities. Once we've got an identified storm track for the event, then we're starting to run models a little bit more frequently. Based on what those model runs are telling us, we're issuing different advisories, calling more people within the flood notification manual, issuing the advisories on the web. Emergency alerts go out, so those are the things that you can RSS feed into from municipal affairs. Forecasters' comments go out as well. So the sort of the left side of that other slide, that sort of goes around in a circulating motion until essentially that the event is complete. In terms of our general operations, we are large rainfall and rainfall on snow event forecasters. We do not do thunderstorm forecasting or localized flooding kinds of forecasts because they're so isolated and hard to predict on those weather models. Again, we run mid-March to mid-October. Critical time is May to July. The far picture on the left was a group of monitoring crew from ESRD that were flying into the Red Deer River at burnt timber gauge. We had lost that gauge completely, needed to figure out whether it was something that could be fixed or not. They were flown in by helicopter. They were able to land at the station site and found the entire rig and cableway had been ripped out of the ground. Not just the orifice, the station was gone, and the concrete block that held that cableway in place had also been ripped out of the ground. So that was not getting put back anytime soon. But even if you'd had a gauge there, the amount of braiding that's going on, the amount of channel erosion and sedimentation transport, no rating curve on Earth is going to work in that kind of situation. So the flows that were being produced by the database while the station was still active and reporting, they're approximately double what we think actually went through there. So on the fly during an event, you're interpreting the data operationally. Is it true? Is it possible? Is the model right? Is the recorded data right? And you're constantly making those decisions. The center picture is Wapers Creek. That one was lost as well. And then the third picture, well, the Highwood River picture, after the event, we'd gotten word that there was a secondary system potentially coming to affect the province with totals of up to 150 millimeters again. Thankfully, that did not happen. But the reality is we were running with a network that didn't exist anymore. Specifically within the Highwood River, there was nothing left there. So we were scrambling to initialize the models again for what was coming down the pipe in terms of what the precipitation totals could be. I would take anything. So the guys in High River from the EOC there were doing flights by helicopter. I said, if you've got any pictures, please send them, because we've got to figure out what the flow is in that river right now to start those model runs. So luckily we got that, but can you see that the amount of sedimentation that was occurring was absolutely incredible. I said we have operations starting in March, but January 1st we started questions about what is the snow? We have lots of snow, what's the flooding potential? And I thought, okay, we struggle with this every year. What is the flooding potential based on snow? And I thought, okay, I'm going to start plotting snow water equivalent data for Little Elbow, Snow Pillow, and the Snow Survey site against Elbow River at Bragg Creek annual maximum instantaneous flows to see if there's any kind of relationship that you can actually use to predict what the flow is going to be in any given year. what you can see here, it's the same data just presented two different ways. We have increasing snow water equivalent by year, and these are the maximum instantaneous flows for those years. And you can see the top 3 snow water equivalent years on record for June at the Little Elbow site. The flows that corresponded with those values are down in the sort of the average range. If you look down at the bottom of that trend, so the lowest snow water equivalent years, you have the third highest flow record in that basin, which is the 2005 event where there was absolutely no snow at all within the basin. This is the estimated flow approximately for 2013. It sits about in the upper third range. But if you start looking at those relationships, I've plotted the June is the blue and the March is the red, just snow water equivalent against maximum instantaneous flows. There is no trend. It's a complete scatter. So what it's really telling you is you will not know what your flooding potential really is until you start to see weather forecasts coming down the line in terms of events that could be occurring. The snow represents risk and possible increased severity of an event, but it does not guarantee that you're going to have an event without that rain. In terms of the data that we look at on a daily basis within the province, we've got about 400 hydrometric stations, about 146 of those we can do forecasts for. We've got about 600 meteorological stations in the province. Happily, about 300 of those are fires and they do their own QA/QC on them. So that's good for them. I want to draw your attention to the picture on the left. This is a really interesting story. So the monitoring crews within ESRD about 2 years ago started working with this idea of having temporary stations that you can transport anywhere within the province to measure water level and different things like that, and have the ability to basically send all of that data into our database real time. And in this case here, we got word from Water Survey of Canada in plenty of time that they were going to take the equipment out of the South Saskatchewan Medicine Hat Shack. They had lost enough equipment, I think. They were going to do what they could to preserve what they had. And because we had that advance notice, we were able to run the equipment out to Medicine Hat. The crew put down 4 orifice lines just in case backups, because those things do tend to get ripped out quite easily during high flows. And I would say there was maybe an hour lag between when the Water Survey Canada station stopped transmitting and when we were getting the new data into the database in Edmonton. So that system, I couldn't have asked any more of that system at that time. And then once the event had gone through into Saskatchewan, we were now starting to put those gauges back into the Highwood and the Sheep because we had no network. We had the event coming and we needed something that we could use for those events. In terms of monitoring for the event, essentially it was 5 basins in play, and we've talked about that a little bit earlier this morning in terms of it's never just one. One gets hit harder than the other ones, but it's usually more than one in play at one basin at a time. So in terms of what we were looking at intensely, if you draw a line south from the city of Edmonton, here, straight down, in this area here, we had about 110 hydrometric stations we were doing QA/QC on and looking at, and about 180 meteorological stations. In that area were approximately 63 forecast points that we were working on for the duration of the event. The problem being, again, I've talked a little bit about that and the loss of the gauges. So 13 were completely destroyed, 13 had erosion or other technical issues. So when 23 or almost half of the stations you're trying to forecast at have no check data at them, it makes it a little bit more difficult to try and forecast flows for downstream. In terms of the loss of that data, it takes a little time to figure out what's happening. So best case scenario, mistransmission. So the loggers in the field collect 15-minute data. They transmit to the GOES satellite on an hour transmission window. And it's a tight window because everything in North America is going out on that satellite. Sometimes it gets missed for one reason or another. You don't know why, if that's the problem, for another hour until you get that transmission back. It could be a problem with the database. It could be a problem with the collect system in Edmonton. Those are reasonably easy things to figure out in a short period of time, although short is 1 to 2 hours. If it's a database problem, we do have a secondary site. It usually takes 3 hours to do a complete flip to that site. The bigger problem is if it's none of those things, then what do? You're seeing strange data, maybe. It's bouncing around. You have a lot of standing waves when you get flows of this magnitude, so you see very strange data. Is it true? Is it not? Making those decisions becomes critical. When you lose the gauge entirely, you've got to send a crew out. And even when it's bouncing, you have to send a crew out. Well, to get a crew out to those sites, it's not a 15-minute drive. You're 3 or 4 hours out from knowing what's happened to the station that you're trying to use. And in most cases, you just proceed assuming that you don't have the station anymore. And I'm going to show a couple of hydrographs here of some sites in the middle portion of the bow. Jumping Pound, we've got Waipress Creek, where you see where it stopped. The database is actually just straight lining, interpolating there. And then Ghost River, which the gauge think is peaked at 1,300 meters cubed per second. Well, the estimates now are, we're thinking it was probably okay up until the point it did this, and then the rest of it's false data. So you've got to be very aware of the data that you're putting into the model when you're proceeding. So these are just some of the model schematics that we run. Essentially, it's an elevation band melt rate model, very simple, 4 pieces of data. We have precipitation data, temperature data, water flow data, and water level data for the reservoirs. That's all you need. You do need forecast values for the precipitation and temperature. We're using some TransAlta data here too, so we're scraping off an FTP site the data that they're transmitting, and that goes directly into the database as well to help us route flows downstream. So this is the model to Calgary. This is the Elbow, Highwood. Once we get down to Calgary and past Calgary, typically speaking, it's just a routing model after that. And then that combines with the models that are coming out of the Elbow, or out of the Old Man. And then we're routing those flows down to Saskatchewan Medicine Hat. Forecasts, again, talked about fires, weather, Environment Canada. We use some stuff from the States as well. We use the snow modeling that NOAA does to help data assimilate the model information. We do recalibrate the models once a week to soil moisture and soil amounts, or snow amounts. In terms of anticipation of a major storm, I talked about this a little bit already. You're making some preliminary phone calls, you're getting a better idea of what the weather forecast is there's some uncertainty in the weather models, and I don't know how many of you look at the hurricane tracks that come out of NOAA, but quite often it's a bullseye sitting there in this big funnel of potential trajectory. I would suggest that that's very similar here. Those large synoptic events, when they're sitting off the coast of Alaska, can hit anywhere from the North Sask down to Waterton Park at that particular moment in time. I remember this well. So anticipation of the 2013 event. I was driving home that day. We just finished up the Fort McMurray flooding incident that they'd had. I was quite happy that it was over, and I get a call from Forestry Weather saying, okay, we've got this system. It's coming. It could be similar to 2005. And what that means in terms of amounts is in the order of 100 millimeters basin averages with up to 200 millimeters convection going on. At that point, operations people are aware, the City of Calgary was aware, and we were getting in touch with a couple of other groups as well. On Monday, started the phone outs to flood-prone areas. It was a very loose forecast at that point because they really weren't sure of what the precipitation amounts were going to be at that time. And I think at that moment in time, Dixon Dam did start their pre-spill. On Tuesday, June the 18th, they had a little bit better handle on what they felt the precipitation amounts were going to be coming out of the models. Depending on the basin, it was between 80 and 160 millimeters for the 48-hour event total, with 12-hour maximums of 50 millimeters, and this is a really critical part to the story of the 2013 flood. In terms of what were happening during the flood, a lot more communications going on. I think within the first 48 hours of the event, there were about 400 calls managed to the River Forecast Center. And again, that's maybe 5 or 6 people dealing with that call volume. During an event, they're managing the calls, they're issuing the alerts, they're doing the QA/QC on the data. We are doing the communications with the different communities, and somewhere in there the forecasting is going on as well. In terms of the event itself, we talked a little bit about those 12-hour intensities. The actual ones that finally came out at the end of the day for the Elbow Sheep and Highwood, they're getting 12-hour intensities between 115 and 140 millimeters. That's about 1.5 times the 1 in 100 rainfall intensity for that area. When you talk about historical events within those basins, it's not unusual to see hourly rainfall rates of between 3 and 5 millimeters with some outliers. This time we were getting 10 to 20 millimeters for almost a continuous period of about 14 hours. So for whatever reason, we were getting almost 3 times the event that we were expecting in some locations. And the huge driver was that first 12-hour rainfall intensity load that was expected and pushed on those basins. And when you have those intensities, it's like rain hitting concrete. There's no infiltration at all. And the snow is not helping because it's like hitting concrete as well. Some different hydrographs here. The upper hydrograph is Highwood River at High River. It's called below Little Bow Canal. The lower one is Highwood River at Deebles Ranch. That's the uppermost catchment gauge within that catchment area. This is the 2005 hydrograph. So you can see there was no snow that year. The rain fell mid-basin. You know, pretty good peak, but it took a long time to happen. Very long duration event. This is your 95 event, so higher snowpack than last year, more snow-covered area, similar initial antecedent conditions. But again, you're not seeing, like it was a higher intensity event. You are getting the peakiness at the upper portion of the basin. This is Deebles Ranch here, and this is High River. The time to rise is 8 to 9 hours. The travel time is 8 to 9 hours from Deebles Ranch to High River in that case. And then this is last year. So we're seeing that intense peak of precipitation that came through. Deebles Ranch took 4 hours from normal flows to it breaking. The travel time was the same, 4 hours maybe to High River. That fits well within the World Meteorological Organization of defined flood, flash flood. So anything that happens within 6 hours of a causative event is determined to be a flash flood. And I did plot the Little Elbow snow pillow melts that were coming off. It was pretty steady in the period before the event, and as well during the event too. And then there's this period of time when it actually did start to snow in that second day. In terms of the communications flow, we're talking with a lot of different groups. MD, Saskatchewan, industry, infrastructure. The public can talk to a forecaster on duty. They don't have exact access that they can call in and ask questions as they can. Communications with the media is occurring during an event. We're talking with our own flood response coordination committee, so that's ESRD's group that organizes their response to flooding. Provincial Operations Center and the EOCs within each of the municipalities. So in terms of projects that we're working on, we've got a lessons learned and partner engagement workshop. That is, finally the draft report's done, so that will be going out to the groups that we met with. There were 10 different group meetings, and came up with a lot of interesting ideas about what we can do in terms of improving the communications with those groups between river forecasting and emergency managers. How to deal with gauge redundancy, those questions were coming up quite a bit as well. Performance measures, project, weather forecast, uncertainty project. I'll talk, if you have questions about these, we can talk later. I know I'm going over. So, event reviews, precip runoff temporal variability study. So I basically identify those locations within the province that are prone to the flash flood. Working with Environment Canada on getting their gridded data directly pushed into the database. Into the models as well. Different partnerships and working groups. We've got the rainfall intensity alarms that we're initiating this year. And improved communication tools, and I really did want to get to this. So there's a couple of things we can do with the products we have. The biggest one that we're trying to implement for this May is basically a River Basins app. So there are difficulties that we have with the website right now that shows the river basin data and the precip and the advisories. Hopefully this is a way to address those. So people can go in, have the app, look at the stations they're interested in. When they go right in, there's a disclaimer, the data is of questionable nature, as it always is before it's QA/QC'd. You can see the advisories and where they are. You can zoom in, see your location. There's some quick information that comes up. You can see the annual graphs, weekly flow graphs, weekly precip graphs, tabular data if you want it. And then you can also have a My Stations list. So if you don't want to slog through the map, you can have a preset selection of stations you like looking at, and have those on there all the time for you to be able to look at.